Our final technique for evaluating capital budgeting projects is internal rate of return. So here are our two projects and their corresponding cash flows. What is internal rate of return? Internal rate of return is the discount rate that forces the present value of a project's inflows to be equal to the cost of that project. In other words, it's the discount rate where a project's net present value is 0. We're going to solve for internal rate of return using our financial calculator because it is precise and it can undertake the many different calculations that's necessary to find internal rate of return in the blink of an eye. Doing so by hand is inefficient, it is inaccurate, and it expends a great deal of effort. So when we solve for internal rate of return using a financial calculator, we're going to enter in a project's cash flows in the same manner in which we did when we solved for net present value. But rather than pressing the net present value key after entering our cash flows, we're going to press the internal rate of return button and compute. For our two projects, Project L has an internal rate of return of 18.13%, and internal rate of return of Project S is 23.56%. We can also solve for internal rate of return using Excel, in that Excel has an internal rate of return function built in. Now, what is the rationale for the internal rate of return method? Well, if a project's internal rate of return is greater than a firm's weighted average cost of capital, that means that the project's return exceeds its cost, and there is going to be some return left over to boost stockholders' returns. The decision rule for internal rate of return is the following. If a project's internal rate of return is greater than the firm's weighted average cost of capital, that's an acceptable project. Whereas if a project's internal rate of return is less than the firm's weighted average cost of capital, we will reject that project. So for our two projects that we've been using as examples, L and S, if those projects are independent, that is, they do not compete against each other, they would both be acceptable projects because they both have internal rate of returns that are greater than the firm's weighted average cost of capital of 10%. If those two projects were mutually exclusive and they are competing against each other, we would accept S because S's internal rate of return was greater than L's, and it was greater than the firm's weighted average cost of capital. I've worked two more examples for you, and along with the financial calculator keystrokes necessary to solve for them, you can get to those by clicking on these links, and they will bring you to the Show Me tutorials. Now, how is a project's internal rate of return similar to a bond's yield to maturity? Well, they are the same thing. They both have a cost, and then they're both investments that are held until maturity. They provide benefits until maturity. The bond's cost is the current price. The benefits are the coupon payments and the return of the par value, whereas with a project, you've got a cost and then some cash flows that occur. So think of a bond as a project. The yield maturity on the bond would be the internal rate of return of the bond project. And you can prove this to yourself by using the cash flow worksheet in your financial calculator for this bond. It's got a cost, and then there are some cash flows that are generated over 10 years. If you plug in all of those cash flows, that would be $90 a year for 10 years. In year 10, not only would you receive the $90, but also the return of the par value. And then solve for internal rate of return. It's 7.08%. But you could also plug in all that information when we solve for yield to maturity on a bond using the time value of money buttons. You end up with the same answer. So internal rate of return, yield to maturity, same thing. We're just talking about two different investments in the financial world. Now this is interesting to note in that managers seem to prefer internal rate of return to the net present value method when making capital budgeting decisions. Of the four methods we looked at, payback period, discounted payback period, we know that they're easy to apply, but they're fraught with all sorts of difficulties. Internal rate of return, net present value, they are the better methods because they consider time value of money and they consider all of a project's cash flows. And there's also a link between the technique and value of a firm. But of the two, when you compare internal rate of return and net present value head to head, net present value is the better method. It will never lead you to a wrong decision. When we are applying net present value and internal rate of return to projects, when those projects are independent, you can use either method. You'll get the same answer. But when projects are mutually exclusive, there are certain circumstances where internal rate of return will tell you to do one thing, net present value will tell you to do something entirely different. If that's the case, if when applying net present value and internal rate of return in a mutually exclusive decision, always go with net present value. It will never lead you astray.